Hi everybody, today we're going to work on identifying regions of sets by shading. When we shade part of a Venn diagram, we're deciding what counts and what doesn't count. Shaded regions represent the elements we're including, and anything unshaded is not part of the set we're describing. Let's start with a single set A. If we shade circle A, we're saying everything inside A counts. Now let's add a second set B. And let's work on shading the intersection of A and B. Remember, A intersect B means we want the elements the two sets have in common, so we're only going to shade the overlapping region. When we take a look at A union B, this includes everything that's in A or in B, so we're going to shade both circles. When we look at the difference of sets, it's important to remember that order matters. Let's start with A minus B. This represents everything in A that's not also in B, so we're only shading the part of A that doesn't overlap with B. Let's compare that to B minus A, where we want elements in B that are not also in A. So even though these expressions use the same two sets, they describe different regions. Switching the order changes what counts and what doesn't count. So let's try to describe some shaded region. In this Venn diagram, we can see everything shaded except things that are in the set A. We can write this as a complement since it's everything in the universe that's not in the set A. Let's take a look at a second diagram. Here, A is not shaded, B is not shaded, but everything outside of the two sets is shaded. This should make you think of union. I can see A and B are put together, but we shaded outside of that, which means we shaded A union B complement. So let's try shading a combination of operations. We want to shade A intersect B complement. Start by thinking about where is A intersect B. It's where the two sets overlap. And now we want to shade everything outside of that intersection. Shading isn't limited to two sets. We could add in a third set, which I'll call C. In the picture, you can see I shaded A intersect B intersect C, so it's the region where the three circles overlap. How would we describe the shaded region below? You should notice that the shaded region only belongs to C. So we have C, but we've taken away A and B. We can write that as C minus A union B. Let's try shading a combination of operations. Here, I want to shade A intersect B and then union that with C. I'll start with the parentheses A intersect B. That's where the two sets overlap. Then we'll union that with C, which means we're adding the whole circle of C, which gives us our final answer.